vai decorrer em inglês, portanto. Okay, good afternoon, everyone. Welcome to this webinar of the Portuguese Plastics Pact, held in collaboration with the Joint Research Center of the European Commission. It's a pleasure to have you with us today for this session, which is exclusively dedicated to the members of the Portuguese Plastics Pact. Before we begin, just allow me to brief introduction to the initiative. The Smart Waste Portugal, as you know, is a private non-profit association with those mission to foster the circular economy across different value chains through education, innovation, collaboration, and the creation of new business opportunities. Today, Smart Waste Portugal brings together a network of more than 150 members representing a wide range of sectors, including industry, retail, academia, research centers, and municipalities. Smart Waste Portugal coordinates the Portuguese Plastics Pact that, as you all know, is a collaborative initiative aimed to accelerating the transition to the circular economy for plastics in Portugal based on concrete targets and measurable results. The pact currently brings together more than 115 members representing the entire national plastics value chain. As part of its activities, the Portuguese Plastic Pact regularly promotes initiatives focused on capacity building, knowledge sharing, and strategic alignment among its members. Today's webinar is a part of this effort and aims to provide insights to the recent key developments that are fundamental to understanding plastic materials flows in the European Union, as well as the application of this data in policy making and strategic information systems. So this session today will include two presentations from the Joint Research Center delivered by Andrea Amadei and Simon Manfredi. Thank you so much, to who I would like to express our sincere thanks and for joining us today. These presentations will address to the EU 2022 materials flow analysis model and the raw materials information systems, both key tools supporting analysis, monitoring, and decision-making to the European level. Before we start, just a few practical notes. The webinar will take approximately 1 hour. There will be a Q&A and answer session at the end of the presentations, and we kindly ask you to keep your microphones mute during the session and to post your questions on the chat so that the speakers can address them afterwards. So we'd like to thanks again to the Joint Research Center for their ability and their participation for joining us today. And now I give the floor to our speakers. Thank you so much. So I don't know if it's Andrea or Simon who wants to.
Yes, thank you for the intro. Again, we are happy to contribute and to expose our work and our outputs. And indeed, we have a presentation, and Andrea will start, and then I will jump in shortly later. Andrea, please.
I hope you can see the screen and hear me well.
Yes.
Good, so I can start indeed. Many thanks again for having us today and allowing us to share our recent developments concerning the plastic material flows in the European Union. And then indeed, as you already introduced, I will pass the ball to Simone for an in-depth overview of the raw material information system. Let's start with the first part of the presentation, where we wanted to firstly provide a bit of an overview of how the issues associated with plastics have been addressed in recent years in the EU policies and legal frameworks. Well, it is easy to see that since the 80s, the EU recognized the challenges associated to plastics. Firstly, with regards to policies that were a bit generally focusing on plastic management in the remit of waste management as a whole in the European Union. And then, if we move closer to 2025, starting from 2015, we see that a set of different legal acts and policies were published tackling specifically plastics. So from a general overview on how waste shall be properly handled, for instance, with regard to the Waste Framework Directive and the Landfill Directive, then we move towards legal acts that are devoted specifically to addressing the challenges posed by the plastic value chain. Those challenges are indeed related to waste, but also to safe and sustainable chemicals that might be embedded in plastic products, the issues associated with releases of pollutants throughout the value chain, indeed as plastic littering, or for instance, the issues associated with packaging and packaging waste, which of course covers as well plastics. On top of these strategic actions that are specifically devoted to the EU horizon, we can also see that the challenges associated with plastics have been at the center of international ongoing actions, such as the Sustainable Development Goals or the United Nations Global Plastic Treaty, really showing how the issues associated with plastics were not only at the centers of this action with regard to waste, but also concerning losses, products design, and overall circularity of the entire value chain. Well, this is exactly why we wanted to support this flourishing set of legal acts with an overview that focused not only on the flows associated with the plastic value chain, but also to assess the related environmental impacts. Here you can see a simplified overview of the specific value chain that we consider, so the system boundaries of the study. You can see that we started with polymers production, fossil and bio-based polymers. We moved towards products manufacturing, and then we reached the consumption phase. Here we can see that after use, products are discarded and reach the end of life and are managed in different ways, those being, for instance, incineration, landfill, but also recycling. Throughout the value chain, we may face losses in the environment that were mapped in the model, and also waste which is mismanaged, which is intended as waste which is inadequately disposed of, scavenged, illegally exported, or treated in unknown manners. And we also tried to estimate these flows as well. On top, we also included trade along the value chain that focuses on the EU 27 for the year 2022, and we included trade of polymers, products, and waste. We did use data from leading EU associations such as Plastics Europe, but also statistics such as Prodcom data, Eurostat data, and also other peer-reviewed studies or other grey literature. To give a bit more context of the study, this is a joint effort that was developed in collaboration with the DG GROW of the European Commission, and indeed serve the purpose of setting a methodological framework that can be used even beyond the sole plastic value chain. As you will see today, we developed this approach for the plastic value chain to shed light on the flows for the entire European Union, but this model can indeed be replicated to systems going beyond the plastic value chain. And indeed, speaking about the methodology that we used, we wanted to show you a bit the logic of this overview. Well, we started with this sector. Here you can see the overview for the sector-based material flow analysis that started with the total production of plastics in the EU. As you can see, this model is really a top-down, employs a top-down approach, because we started with the total plastic production, but then we leveraged information concerning the specific sectors' shares of the plastic which is produced in the EU, so meaning which are the sectors that are then using these plastic products. And we use those information to split the overall plastic production into a variety of different sectors. Here you can see, for instance, that we moved from one single number, which is the entire production, into a set of different material flows for each sector under scrutiny. Of course, when we have this granular overview, we can then aggregate all results together again, obtaining the overview for the entire value chain. But how is this done in practice? Well, if we zoom in into one of these specific sector, you can see that actually what we did is that we compiled a set of matrices encompassing data that were retrieved specifically from stakeholders, because this project was also leveraging data that were retrieved through two stakeholders consultations, where we asked experts to provide their feedbacks and insights on the key aspects that we wanted to map in the plastic value chain. We also complemented these statistics and information with data from literature, and this enabled us to map the information moving from one life cycle stage to another. So from one stage, for instance, consumption, to the other stage, for instance, waste being generated, through mass flows. So what we did is that we connected each of these stages or nodes of the value chain with specific flows. The amounts of each flows were derived again through these specific consultations. These flows were then converted into percentages that enabled us to keep track of the mass balances within all of these life cycle stages. On top of the analysis of flows, as I mentioned, we also wanted to assess the total environmental impacts associated with the overall plastic value chain. And this is important because when we were developing the study, actually, we realized that there was a lack of information related to the entire plastic value chain. Of course, plastics in general and as a sector is something which is tackled in literature, but most studies focus on specific sectors, such as packaging, for instance, or specific products or polymers. But a real eagle-eye overview of the entire plastic value chain was missing, not only at the level of flows, but also at the level of impacts. That's why we wanted to convert all of this information, again, mapping flows, so masses, to impacts. And we considered, again, the same system boundaries that you have seen earlier in this presentation, and we developed ad hoc models to capture the specific impacts of the plastics that we consume in the entire EU economy. And we did that by using a set of methods that were applied for each of the specific stages of the plastic value chain, mapping the related impacts for each of the specific stage per kilogram that were then upscaled to the entirety of the plastic value chain through the flows that we have mapped at the level of the material flow analysis. We did that leveraging the environmental footprint method, which is the LCA, so life cycle assessment method recommended by the European Commission, that encompasses a total of 16 impact categories, so climate change plus other 15, that were used again to map the impacts not only related to greenhouse gas warming, but also with regards to other environmental issues. And we did that again by maintaining the level of granularity that we achieved for the material flow analysis, so both polymers and sectors. So here you can see an overview of the results concerning the material flow analysis, and this picture shows the entire plastic value chain for the European Union and the related flows, so masses. You can see a set of gray vertical bars, which represent specific nodes, so life cycle stages of the plastic value chain, and each color of this chart instead represent one of the sectors that we have checked in our analysis. You can see different colors, and actually if you look on the legend on top, you can see that we also included less explored sectors, such as, for instance, textiles, healthcare, and fishing, which are typically neglected in literature when we speak about plastics. So the key things to note from this chart is that really the blue part is leading the most of the flows, especially considering consumption. You can see here that packaging covers more than 33% of the total plastics which are consumed in the EU. And actually, if we move past consumption, we can see that packaging also plays a crucial role in the total amounts of plastic which are sent to recycling facilities. We mapped here, highlighting here mechanical recycling, but we also included some information concerning chemical recycling. And indeed, most of the plastic waste that goes to this facility, again, comes from the packaging sector. Well, when we look at the outputs of these recycling facilities, we can imagine that those outputs will then be used to manufacture plastic products that will be used again in new sectors. We tried to map the specific fate associated to these recycled plastics, meaning which are the sectors where the recycled plastics are most likely to be used. And here you can see that we highlighted the construction sector, meaning that out of the total amount of plastics that is recycled in the EU, most of it is then used to manufacture new plastic products that are related to the construction sector. So overall, we recycled around 7.3 megatons of plastics, meaning that the end-of-life recycling rate, when we compare this number with the total waste which is generated, is close to 17%. Another interesting findings that you can see from this chart, apart from the complexity of the various flows and nodes that we tried to map in this overview, is that moving from left to right, the charts gets thinner and thinner. And indeed, if we consider the final downstream flow, meaning the recycled amounts, and we compare that amount with the upstream, so the produced volumes, actually the ratio is only 12%. Well, another aspect that I mentioned briefly earlier is the fact that we did not only check the information at the level of sectors, but we wanted to provide a granular overview that was not only encompassing an overview of flows at the level of sectors, but also the polymers that are mostly used in each of the sectors that you can see in this overview. Well, this granular overview enabled us to move from this EU-wide overview to a specific sector overview. So this is only the packaging sector. So the blue part of the previous chart was extracted. And you can see here a zoom into the packaging sector alone. So this is a Sankey diagram showing the flows related to the packaging sector alone. And then from this overview, we can move into granular detailed overviews at the level of polymers that are flowing in the EU within each of the sectors. So in this case, polymers related to the packaging sector. So this is the type of granular details that we can achieve through the models that we have developed. To show a bit of the highlights of the results, we think that it is important to focus also on the relevance of each sector. We have discussed indeed the importance of packaging, but also construction shall not be neglected, as you can see from this pie chart. But on top of these, it is also important to mention that a set of polymers, meaning PE, PP, PVC, PET, and PUR, together cover more than 70% of the total production in the EU. And actually, out of the total amount of post-consumer plastic waste, so again, moving from the production to the end of life, out of these 36 megatons of post-consumer plastic waste which are collected, around 8 megatons are sent to European recyclers from the packaging sector alone. Despite this, you can see from this bar plot on the right part of the slide that only 34% of the total waste being generated in the packaging sector is actually sent to recycling facilities, with incineration and landfill playing a significant role still in the EU. Indeed, their only incineration alone is higher than recycling volumes. Well, when we consider these 7.3 megatons that are used to manufacture new plastic products, what I mentioned earlier is the fact that we mapped the specific fate, meaning which are the sectors where these products are then used to manufacture new plastic products. But we can also map the origin of the waste which is used, which is indeed recycled and then used. So here you can see that more than 5 megatons of these 7.3 are actually coming from the packaging sector. Again, stressing the fact that it is probably the one sector with the highest collection and recycling capacities in the EU, but showing also the untapped potential for the other sectors as well. On top of these flows that refer to production, consumption, and losses and waste, we indeed mapped also losses and waste mismanaged, as I mentioned earlier. We can see that starting from production, from production and manufacturing, and then waste management, and also consumption. In between, we can see that losses may occur in several stages of the plastic value chain. What we did is that we tried to map the losses that may occur, meaning plastics which is lost into the environment along the value chain. So not only during consumption, but also through waste management, for instance, or production. And we used a specific approach on top of other sources to map these losses, which is the plastic leak method, which is a loss and release method that enables us to map specific losses of plastics and then to track them throughout their loss fate up to the final environmental sink. As you can see, around 3.7 megatons of plastics are lost throughout the value chain. And this covers macro and microplastics, which are lost again. And the difference there is the dimension of the plastic item or the plastic piece, which is lost into the environment. And most of them are actually lost during use, for instance, when textile items are washed. And soil also represents a significant environmental sink on top of water losses. It is also important to note that part of these amounts are actually recollected informally by waste pickers, for instance, or also through street cleaning. And these amounts were mapped in our model. Well, this refers to the plastic which are lost into the environment, but there is also another significant flow that refers to plastic which are mismanaged. This refers to plastic which are illegally exported, scavenged, disposed in open dumps and sanitary landfills, or have an unknown fate. And this cumulatively amounted to 3.6 megatons of plastics. And it is indeed a significant statistics because this is an aspect that is typically, again, neglected in literature, but cumulatively, if we look at these two numbers together, we can see that the mass of plastic lost and waste mismanaged in the EU resulted to be basically comparable to the total amount of plastics that are recycled. So, as I mentioned, on top of the assessment of the specific flows related to the plastic value chain, we also tackled the impacts related to these flows. Here you can see the overall results showing the life cycle impacts associated to the entire plastic value chain. On the left part of the chart, you can see a y-axis, which is covered by acronyms that refers to the specific impact categories, so the environmental issues that are related to the environmental footprint method. For instance, the first row represents CC, so climate change impacts, but you can see moving down that also other impact categories are collected. Again, those 16 that I mentioned earlier, for instance, human toxicity, particulate matter releases, eutrophication, and so forth. Each horizontal bar plot represents the specific impacts associated to that environmental impact category. And the total environmental impacts for each bar plot are represented on the right part, on the right y-axis of the chart. And each color represents a specific life cycle stage of the entire plastic value chain. Well, you can clearly see that if we look on the first bar plot, which represents climate change, along 252 megatons of CO2 equivalent are emitted throughout the life cycle of plastics, and more than 50% comes from plastic production alone, so the blue part of that horizontal bar plot. But packaging also plays a crucial role here because it contributes to around 30% of those impacts. Well, it is also important to note that part of these bar plots go below zero, as you can see here highlighted in blue on the left part of the chart. These are credits related to the materials that are recovered through recycling technologies, but also energy, which is recovered via plastic waste incineration. Well, what you can note if you look on the bar plot on the far bottom left of the chart, of the slide, you can see that the benefits of the part that goes on credits, so savings related to climate change, are only possible if recycling is put in place. But if we look at other impact categories, again, the other 15 of the of the product environmental footprint, you can see that there are credits, so benefits achievable also via incineration. So the energy recovery consequent to plastic waste incineration that are also playing a significant role when we look at the entire environmental pressures of the plastic value chain. On top of these aspects, there is also those related to waste mismanagement, because we tried to map the impacts associated to the potential exports, the illegal export of this plastic waste that could end up in unsanitary landfill, open dumps. And these are actually playing a crucial role in toxicity-related impacts, despite the flows being minor compared to huge volumes, for instance, at the level of production. Well, on top, an aspect that I wanted to also flag is the fact that we included impacts associated to trade. The imports of polymers and products were captured within the impacts associated to the EU consumption, because those are driven by our consumption needs. Also, these enable a consistent approach in case another geography would like to assess their own environmental impacts in the same manner as we did, because our export would be their imports. So we ensure to avoid double counting there. But the production of polymers and products that occurs abroad are mapped in our model, and they actually plays a role indeed, because these are steps in the value chain that are extremely impactful with regard especially to climate change. And indeed, you can see that those should not be neglected because they amount to around 90 megatons of CO2 equivalent. But to streamline a bit the results concerning the environmental impacts of the plastic value chain, it is nice to see them with regards to the total consumption volumes of plastics that each EU citizen actually consumes each year. You can see that from the 63 megatons of plastics that are consumed yearly, so an average of 139 kilograms per person, there is a release of 4 kilograms per kilogram of consumed plastics, 4 kilograms of CO2 equivalent per kilogram of consumed plastics along the life cycle value chain of plastics indeed. And if we zoom into the various stages that are playing a key role in driving these 4 kilograms emitted, we can see again the role of production and trade, which are again basically mostly related to production impacts occurring abroad, but also manufacturing and recycling, despite being the leading asset concerning credits, is only showing with this minus 0.1 kilograms due to the fact that only a small amount of plastics are actually sent to recycling facilities in the EU. So the sheer amount of the plastic flow in there plays a role in this overview. To conclude, we would like to stress some key takeaways, starting with a bit of a refresher on what we have seen. We consume around 139 kilograms of plastics, and more than 42 megatons of plastics waste are generated each year, with only 7.3 megatons of recycled used again by manufacturers. Concerning the losses and waste being mismanaged, actually those are playing a crucial role in the plastic value chain, because cumulatively they amount to a volume which is similar to the total recyclates being generated. Concerning environmental impacts, we emit more than 252 megatons of CO2 equivalent if we look solely at the climate change impact categories, but indeed the added value of the environmental footprint is that we can stress the importance of impacts beyond climate change. And production and manufacturing are actually covering more than 50% of those impacts, plus the influence of trade, as I mentioned. And indeed, packaging plays a big role, not only with regards to flows, but also with regards to the impacts associated to the value chain. So to wrap it up, we flagged some aspects that relate to the potential way forward concerning the value chain itself, because we have recognized that there is a lack of granular and polymer-specific overview that provides information not only on a certain specific life cycle stage, but from production to the end of life, trying also to map these less known flows. And this is key because indeed there are some less known flows and sectors, such as, for instance, trade, mismanaged plastic, recycled plastic fate, or healthcare and fishing as sectors that are really key to be explored to meet the EU ambitions concerning the circularity and sustainability of the plastic value chain. On top, another important aspect is that a thorough mapping of the additives and composites that are embedded in plastic products is crucial, because this information can help us to map the specific fate associated with recycled plastics, understanding potential issues associated to downcycling, and really show a path towards this meeting this untapped potential for the circularity of the value chain. Well, here I would like to pass the ball to Simone for the second half of the presentation concerning the raw material information system.
Perfect. Thank you, Andrea. So we have heard about all the work done by Andrea and the team working with Andrea on the plastic value chain, so on a specific value chain. But we also have a more general information system dealing especially with metals and minerals. It's called the Raw Materials Information System. Next slide, please. So this is a system that is considered the official system for the Commission, exactly on metals and minerals. But specifically and more precisely, we focus a lot on critical raw materials and strategic raw materials. This information system has been up and running since 2015. And that is because that year we got an explicit mandate with the first Circular Economy Action Plan. Beyond this document, we have been mentioned and supported by a number of policy documents. The overall concept and scope is to try as much as possible to make information data analysis on raw material more available and accessible and coherent. As I said, specifically for critical and strategic materials. The information that you can find the system relate a lot to aspects like circularity, competitiveness of different value chains, but also their sustainability, autonomy, and resilience. To do that, we are not alone. We have a team of roughly 12 individuals here at the JRC, but we have an extensive knowledge network with representatives from, of course, DG GROW and other DGs, but also member states, various industrial stakeholders, academia, and I have to mention a lot of Horizon projects, and not only Horizon. There are many more details in a document that you can download directly in the information system, which is called the roadmap. Next slide. All right, so from the homepage of the RMIS, you can access this page called Topics, RMIS Topics, and this cloud appears. Here, the size of each area is not random, but is proportional to the number of content, the number of pages connected to that topic. So you see some topics are, say, more prominent than others. But this is continuously changing, so it may be a bit different today, let's say. Now, this may seem a bit overwhelming because we cover so many different aspects, but to make this more clear, we try to compile, based on all of this information, we try to compile so-called profiles, which are summaries for individual raw materials, individual countries, and individual sectors and technologies. And the next slide. So these profiles can be accessed through the top of the homepage of the RMIS. You see country, raw materials, and technologies and sectors. So for the raw materials, we cover more than 100 individual raw materials. And among these, there are all the critical and strategic according to the triennial criticality list developed by the Commission. The next criticality list is due in roughly 1 year. And for each raw material, we have more than 30 indicators covering most of the supply chain, so from reserves and extraction to the final end of life, and also covering aspects like sustainability and circularity. On the country dimension, we have country profiles. we cover EU27, we call most EU enlargement countries, we cover most African countries, Latin American and Caribbean countries. And I say here many more, and I refer especially to the countries where a partnership on raw material has been established or is gonna be established in the future. So we try to provide information also for these countries, emerging countries. We also have profiles for technologies and sectors, and these are in particular 15 technologies in 5 strategic sectors. And by the way, these studies have underpinned scientifically specific parts of the Critical Raw Materials Act that you are certainly familiar with. All right. So these are the profiles, and now, well, I invite you to really go online and play with your MIS rather than listening to me. It's a lot more entertaining and inspiring, I think, to look directly in the platform. Many of the section and the indicators are interactive, so it's nice. And most of the information can also be downloaded. And if you cannot download, you are welcome also to contact me and the team, and we'll try to respond. But to connect with Andrea's presentation, of course, as I said, we cover many different aspects and we cover specific value chains, including the plastic and the work on plastic. So you find in our MIS a specific entry point, a tile for this topic. You find the result of the MFA and all the links to the relevant publications and also those that will be developed in the future. I think we are finished, and we have some 20 minutes for questions and discussion. And thank you for the opportunity.
Thank you both for the excellent presentations. It's really interesting information and really interesting database that we can search and look for more information. So now I open the questions. If someone want to do a question, if you have some problems in English, you can do it in Portuguese and we do the translation, or you can write it down on the chat. So maybe you can stop the presentation now. Okay, we have, thank you. We have João Letras from Sociedade Ponto Verde. João.
Hi, good afternoon. Thank you for the presentation. Unfortunately, I wasn't able to look at all the slides because I had to interrupt twice for phone calls. But in any case, thank you very much and congratulations on the good work. I'm not sure if you addressed the topic that I'm about to ask, which is when we think of plastics consumption and when we think of waste generation, how did you tackle the issue of composite materials? So plastics that are used in packaging items that are not solely comprised of plastic, because I'm assuming it's a lot easier when you follow the value chain and you're in the plastics industry and you're making a plastic bottle, a plastic jug, a tray, something like that. But when we get into applications, for instance, like laminated papers and stuff like that, which may have even different end uses as packaging waste, how is that addressed in your work? Thank you.
Thanks a lot. So maybe I can try to answer this. Maybe it's not apparent from the study, but actually we tackled the sole components of plastics, even if the items are composite materials. And we did that by combining information that are available at different level of granularity. So I've mentioned that the study is a top-down approach, but at some specific points of the value chain, we also leverage the information that are coming from bottom-up studies that enabled us to tackle these specific plastic amounts. For instance, if you think about the transport sector, which we mapped, actually we referred solely to the plastic share that are used in vehicles when we speak about the transportation sector. So to do this breakdown and the specific overview, what we did is that we relied not only on, again, bottom-up study. There are specific studies that really mapped flows of polymers that were then associated to specific products. So we knew the specific shares of polymers, for instance, for the laminated films within products that can be used to allocate the specific amounts to the consumption items, consumed items, for instance. But we also had a previous study that was used as underpinning data source, and you will find a reference in the manuscript there, which came out in 2021 that leveraged specifically Prodcom information. Well, in Prodcom, you can see specific Prodcom codes. So this Eurostat database provide information related to items that are consumed in the EU. So production, import, and export of a set of items, including plastic specific items, so 100% fully plastic based, but also items that are consumed in the EU which have a certain share of plastics. So what we did is that we extracted the entire database, and we went one by one to each of the specific entries to allocate the plastic share to that specific volume, which was reported in Eurostat, and we used that amount to then arrive at the consumption estimate. So the numbers that you have seen there basically have all of these aspects together and combined. And indeed, probably to find a more adherent overview, it's nice to see these polymer-specific detailed Sankey diagrams where you can track these into the various applications and sectors.
Okay, thanks.
There's some more questions? No? Okay, so maybe I can do a question. So, the data that you use is from 2022, but in the future, is this model? Can we? How can I say? Can we? In the future, are you going to study it again with new numbers, or the model can be inputted with the new numbers, so we can have the results? I'm sorry. I don't know if you could understand my question.
Yeah. I will tackle this point on two levels. So the first one refers to the fact if the model is updatable for coming statistics in the next years. So the model as such, meaning a combination of percentages and flows and nodes, it is indeed updatable, meaning that we have not only the model with regard to the Excel structured calculations, but also as ad hoc tool that enable us to create the Sankey diagram that you have seen in the presentations. And both can be updated with new data that may be there in the future. Although, of course, it is important to flag that this study provided a snapshot referring to a specific year of the plastic value chain. But it is also true that the model, the plastic value chain is dynamic. So like plastics coming from previous years may be discarded this year depending on the sector. So there is a degree of dynamicity, pass me the word, with regards to the plastic value chain. That shall be considered if this model as such is used to replicate a forthcoming year or used to assess trends up to a specific year. And indeed, so numerically wise, it will be possible. It will be possible because we also included some emerging stages, such as, for instance, chemical recycling. So if an increase in chemical recycling facilities is envisioned in the future, of course, this can be already tackled in the model because we have that specific dimension already embedded there. But if there is a need to use this for sort of foresight play, then we have to think about, first of all, the fact that the lifespan of products may differ from sector to sector. So when we move from a static MFA to a dynamic MFA, then we have to associate probability distributions to the product lifespan to assume how and when they will be discarded when we use it dynamically. And also this poses a challenge when we think about the environmental impacts associated to the plastic value chain, because it is true that we can alter the model to show flows, but then when we speak about impacts, and especially impacts in the future, then the picture becomes a bit more complex, because even though we may have some information related to the impacts of new technologies, we can and should also assume variations in the energy mix that will be there in the future, causing variations in the overall impacts, because of course there is not only the foreground emissions related to the production as such, but also to the electricity being generated and used in the production facilities that may change the picture. So there are specific things that shall be carefully being considered when these are used for future projections.
Okay, thank you. Any questions? No? So one more question for me. For if our members want to look a little more deep on these studies, what is the best ways to read the study that we already publish in our newsletters? Or is there a website? Is the platform that Simon presented? What's the best way to look at it more carefully and to understand it more carefully?
Yeah, I can take here the reply as well, Simone, if you don't mind. Just briefly, definitely the report is structured in a way that not only provides methodological details concerning the assumptions and the specific logic of the overall model, but really the annex section is quite thick on purpose, because we wanted to be as precise as possible and as replicable as possible, shedding light on all the punctual assumptions, data, information that we used for the model. So definitely do not neglect the use of the annexes in the report, because we've been thorough in providing also all the entire list of transfer coefficients for all sectors and all stages. So really, we will find a lot of information there. But on top of this, what Simone mentioned, so again, the raw material information system is much more user-friendly than a PDF, and also much more fun to use. So we again encourage you to go there, and especially when you will land in a web page concerning plastics, you will see that the Sankey diagram compared to the static images that you can find in the PDF is actually more dynamic, in the sense that if you put your mouse on top of a specific flow, there will be a pop-up appearing showing details related to that flow. Because as you have seen from the presentation, really the complexity of the value chain is huge. And we tried as much as possible to show the complexity, but also having some specific numbers in the chart. And the best result was the thing that you have seen earlier in the presentation, but it is indeed complex to see solely from an image the specific values that are embedded within each of the flows. That's why I suggest also to go there and play with the model there, because you can really see the links, click on the links, it shows the numerical number, but really everything else is also, of course, in the report, and feel free to reach out in case of questions, definitely.
Okay, thank you so much. So if you don't have more questions, no, I just want to thanks to Andrea and Simon for these presentations, and for all your work and all the work you've been doing, and also to the GR Center. I hope having a GR Center in some more webinars of the Portuguese Plastics Pact. There's a lot of work going on there. So thank you so much for being with us, and thank you so much for all the persons who were assisting this webinar. Muito obrigada a todos. So we are closing the session now. Thank you so much.
Thank you for this chance and for your time and availability. We can keep in touch whenever needed. Thanks.
Okay. Thank you so much.
Indeed, many thanks.
Bye.
Bye-bye.
Bye-bye. Bye-bye. Have a nice day.